This is the physics video submission for Group Eggplant. Group members are Ruby Maldonado, Josiah Ponte, Danielle Thompson, and Jatai Jin. Section 0, month September, and our instructor is Donald Johnson. In this video, we'll explain how physics is related into music production and show production. Most people think that there isn't any science behind making music or putting together production, when the reality is all the equipment from your basic instruments to the speakers on stage would not exist without physics.
That's right, Ruby. There's a lot more that goes into setting up a stage for, like, say, a Beyonce concert or even one of the Olympic events. We who are responsible for making the magic happen have to know at least the fundamentals of physics, which heavily involves mechanics, acoustics, optic heat, electricity, magnetism, and etc. If not, most of us would be fried by now.
For those not familiar with electromagnetic radiation, the music and sound that we hear from musical instruments, or in fact, any noise, are also energy waves and have a wave nature. The music and sounds that we hear functions very much like electromagnetic radiation. The only difference is that sound waves need a physical material such as air, in which to propagate or be transmitted or transported through to reach the person listening to the sound. Sound waves cannot be transmitted through a vacuum. For example, the space between the Earth and the Sun is almost a vacuum.
How a speaker works. Speaker driver cones are typically made from paper, plastic, or metal. This material moves back and forth and creates changes in air pressure. These are called sound waves that ultimately arrive at your eardrum and cause it to move back and forth in a corresponding fashion. This causes you to hear the sound. The cone is moved by an electromagnetic process that's caused by a coil of wire, called the voice coil, at the base of the cone. The electromagnetic pulse coming from the amplifier drives the voice coil, and the voice coil interacts with a permanent magnet attached to the speaker cone or dome, whatever shape it may take.
So now that we know how speakers work, our group experiment focused on Faraday's law of electromagnetic induction. We used a 22-gauge enamel-coated copper wire, an extension cord, and aluminum plate to present this. When the current flows through the coil, the opposing magnetic field is created. This amount of current causes the coil to repel from the aluminum plate. In our first attempt, the coil was too heavy and gravity outweighed the resistance, causing the coil to only appear to vibrate off of the plate. When the coil was reduced, it's easier to see this reaction. If we had tied down the coil, we'd have been able to control its movement, much like the magnets in a speaker.
So as you can now see, even what we would like to believe to be a simple speaker includes the laws of physics. Just the simple construction of a speaker alone is not what most of us thought it was. Just imagine using the same speaker to set up audio for a venue as big as a dome, or something as small as a recording session. It's important to know how to do these things and why they need to be done that way.